Trains crossing. Uh, this is one of the many applications of relative speed where we'll have to derive some results beforehand if you want to solve questions in the examiner in a competitive amount of time. Like you can solve everything from scratch, that's fine, but these results really help to finish up a question in a competitive time frame. Now, uh, I specifically say trains crossing now because the crossing part is more important than the trains part. You don't assume, and I've seen people do this mistake, that the question is from this subtopic just because the word trains is mentioned in a question. You could have questions that contain trains which have nothing to do with an object crossing another object. You could also have questions that don't have trains in them where an object is crossing another object. I've seen questions where a ship is overtaking another ship. Same concept. The crossing part is more important than the trains part. Please know this first off. Okay. Now, uh, so what we are basically dealing with in this subtopic is an object with some length will take a certain amount of time to completely cross another object which also may have a length. So typical example is a train is overtaking another train, right? Both trains are moving forward in this direction. The one above is faster, so slowly it will gain on the one below. So after some time you will see that I'll call them A and B again. Sometime later B will be here, A will be here. Sometime later B will be here and A will be here, and sometime later A would have completely crossed B. So the crossing starts at this point where the front end of A coincides with the back end of B, and the crossing is done at this point of time where the back end of A coincides with the front end of B. This is basically how it happens, and we are usually interested in finding the time taken to cross if other data is given to us, and the data generally involved is the length of the first train, the speed of the first train, the length of the second train, the speed of the second train. If you are given these 4 bits of info, you can find the time taken to cross. The formula is pretty simple, but let's just look at the derivation as well. There's not much of a derivation, just an explanation of how our relative speed principle is applied. So you have this train with a length of A, LA, and the speed of SA, and it is overtaking another train with some other length LB and the speed of SB. Now, I want you to look at this from the point of view of somebody who is in the second train B. Clearly, when he's looking inside the train, he doesn't see his seat or his window or anything moving, right? It's stationary because basically he's sitting inside and is moving at the same pace that he is also moving in. So what he is going to see, or it could be somebody in the train, what he is going to see is that from his point of view, his train is stationary. You only notice that it's moving when he's looking out onto the platform and sees that the platform is flying backwards with respect to his position. Otherwise, you don't see that. So from his point of view, uh, the train A starts at this position. That is the position at which the train A starts crossing. And sometime later, the train is here with respect to his own train B. This is the final position. Initial, final. With respect to my position, what am I seeing the other train do? Initially they're behind me, I'm looking way back to see the front of the train, and then later I see that the back of the train is just in front of me, right? So we want to look at it in terms of what is the distance that A has traveled with respect to B, right? It's a sort of relative distance, right? What is the distance that A has traveled with respect to B? You will see that it has traversed this much distance. You can compare the initial and final positions of the back of the train or the final initial position of the front of the train, doesn't matter. The distance traveled is LA plus LB. So the relative distance, right? What the train A is, how much the train A has moved with respect to the train B is LA plus LB. It's the combined length of the two trains. And the relative speed, as we have already discussed, because it's the same direction, is SA minus SB. And the time taken to cross is simply the fraction, distance by speed. It's LA plus LB by SA minus SB. This is for same direction. If it is for opposite direction, you can simply put plus instead of minus and you have the answer. The time taken to cross is LA plus LB by SA minus SB. This is a train crossing another train. This is the most general form of this equation. Using this equation, you can find other things like the formula for a train, the time taken by a train to cross a platform. So you have a train which is not stopping at this particular platform, it's just whizzing past. How much time does a train take to cross the platform? You can just consider the platform right below. The platform as a stationary train, it's nothing else. So train crossing platform is just SB equal to 0, because the platform is a stationary train. So then the formula becomes T is equal to LA plus LB by SA. You can also have a train overtaking a car. So you might have a road parallel to a track and the train is traveling faster than the car. How much time does it take for the train to overtake the car? So for the purpose of this question, the car's length is negligible compared to that of the train. So the car is basically a second train that doesn't have much of a length. It's so small that you can ignore it. So that's basically LB equal to 0. And then the time is LA by SA minus SB. Because we are saying overtake, I'm not gonna write plus or minus. It depends on the question. If the question says a car is going in the opposite direction, you would obviously write plus. But because I said overtake, I'm simply writing LA by SA minus SB. That's number 3. And 4 is a train crossing a pole. Some telegraph pole is sitting, just standing there, not moving. It's basically a motionless car. So it has SB equal to 0 as well as LB equal to 0. And the time taken is simply the length of the train divided by the speed of the train. Straightforward. Notice that they're all special cases of this general formula where different things are being equated to 0. And this is basically the approach and the formula for two objects with lengths crossing each other, or they might be one might be overtaking the other, or they might be going in opposite directions and simply crossing each other. This is the formula.